Hi, and welcome to the next part of the lesson. What we do now is we're going to move on to lessons of inference, or lessons of replacement, or rules of replacement. Rules of replacement. And all the rules of replacement is the rules of replacement, if we go back to that original sheet, are a series of statements that are logically equivalent. If you look here, you have these 4 dots. That's basically like an equal sign, but it's an equal sign that says logically equivalent. And so if we were to do a truth table with, P, and this is bar P, we would find that if P could be true or false, and if it's true or false, then the bar would make it false or true, and the next bar would make it true or false again. And so they would be logically equivalent. The main operator would be logically equivalent with the main operator of the other line. And so we can go down all of these rules, and they all have different names, and there's 10 of them, and we can find that they're all logically equivalent. Now, the first one's just double negation. And anytime you have P, if you have the negation of the negation, then it's true. So if you say, like, I'm not something, then you're saying you are. Like, I'm not going to the store. That means the same thing as I'm going to the store. Something like that. Sometimes people use double negatives all in their regular speech. Like people say there's, oh, I always hate coming up with that example. It's like I hear it all the time. People speak with double negatives, but I can never think of them when I want to. But basically, anytime you use a double negative, it's the same thing as saying that the original statement was true. De Morgan's rule is basically a way to take. So a few of you, when you had these statements with the bar outside, you would simply say, oh, well, then it could be bar P plus bar Q. Well, this statement here is saying it's not the case that Paul and Quentin are here. So it's saying it's not the case that it's not the case that you are tall and handsome, right? It's not the case that you are happy and wealthy, right? It's not saying that you're It's not saying that you're both not wealthy and not happy. It's just saying it's not the case that you're not not wealthy and happy. So it's the case that you're either not wealthy or it's the case that you're not happy. But it's not the case that you're both wealthy and happy. And so to say, if you were simply to move the bar in with the P and the Q, then you would be saying you're not wealthy and you're not happy. But if you say it's not the case, parentheses, that you are both happy and wealthy, you're really saying you're either not happy or you're not wealthy. Then the same thing is true here. If I said it's not the case, neither you are wealthy or happy, neither you're wealthy nor happy, then I'm really not saying you're either not wealthy or you're not happy. If I'm saying you're neither wealthy nor happy, I'm saying you're not wealthy and you're not happy. Okay? Now, I don't know that either of those are true. I think most of you are surely wealthy and happy, right? Anyway, so what happens is that when you bring that bar into the parentheses, if you have a plus sign, and this only works with pluses and wedges, when you move it in, you can put it in front of each individual letter, but the plus has to turn to a wedge, and the wedge has to turn to a plus. And that's basically all it does. And you can do this in either order. If you have a bar P, wedge, bar Q, you can bring it into parentheses by changing it to parentheses around it and changing that to a wedge and moving the bar outside. And you can go both directions. Material implication is basically this, where you have P, or if P then Q. If P then Q is saying anytime Paul is there, then Quentin will be there. So it means the same thing as either Paul is not there or Quentin is there. Because if Paul is there, then Quentin will be there. But if Paul is not there, well, Quentin might or might not be there. But we know that it's the case that anytime Paul is there, Quentin will be there. So we know that Quentin will be there in that case, or we know that Paul's not there. So we can take that and change it. So if we have this rule, like, one way to do it is like, if you don't pick up your room, then you'll be grounded. So it's either the case that you didn't pick up your room or you're grounded. Okay, you negate the antecedent if you don't pick up your room, so you negate it, which is would be not pick up your room. So pick up your room or you are grounded means the same thing. Material equivalence is basically taking this P triple bar Q statement, and basically all that's saying is that it's really saying if P then Q and if Q then P. And that's all a triple bar ever meant, and so most of us know that to be true. It's also the case that a triple bar can mean another thing. It can mean P plus Q wedge bar P plus bar Q, but we won't have to worry about that right at the moment. And then finally, distribution is basically the idea that if you have a statement where you have a wedge, like a singular statement with a plus, and then you have another one that has a wedge in parentheses, you can't just simply combine it all together, but you can take and you can make P plus Q, so then make the wedge the main operator, and then put this one over there with the other one and make it P plus R. This can be P or Q plus R. The one in parentheses becomes the main operator, and then the antecedent goes with the other main operator with this one as well as that one. And so this is a statement like Paul will be there and Quentin or Rick will be there. So that means the same thing as Paul and Quentin will be there or Paul and Rick will be there. Okay? And that should make sense to you. If Paul is there and Quentin or Rick, then it's the case that Paul and Quentin are there, or it's the case that Paul and Rick are there. If it's Paul or Quentin and Rick will be there, then it's the case that either Paul or Quentin is there and either Paul or Rick is there. That one's a little bit harder perhaps to follow, but the idea is that you can change it over, which would then allow you to do a simplification, get like saying like P wedge Q down and out. Now, we come back over here to our Blackboard page and go down, and if we come here, there are the logic problems and the answers. If we click the logic problems, with the rules of replacement, instead of giving you simply problems like this as we did previously, we come down to where it's actually at. You will be given problems in which you will be asked to find what is equivalent. And so you will be given a series of statements, and you'll have to do matching. And you'll have to draw an arrow, and so you have A horseshoe B. What could that mean? What rule could be applied? And so you'll look down, and you'll find the one that can be similar, and then write out the rule. So A horseshoe B means the same thing as bar A wedge B via implication. And so you would draw a line. And you would have things like A plus A is a tautology to get A, and A equals B or A triple bar B is the same thing as this here, and so you use these in order to reach it. And then finally, I'm going to go ahead and finish up the other 5 rules of implication, because apparently I guess I didn't really realize that I had done it that way, but it's also the case that some of these have all of them. And then finally, if you go down at the bottom, there's a final set of problems, and there's a really long set that has a whole bunch of implications, has a whole bunch of rules of inference, and has a whole bunch of these proofs. And my reason for doing that is you have a whole bunch of these in order to give you a really good chance of thinking about this. And then finally at the bottom, one last part of the test will be that I will have questions like use these rules of inference and ordinary rule, which one's being used. And it'll say something like, if John is late, then he will not be admitted. He was admitted, so he must not have been late. And what that's doing is that's using a modus tollens. It's taking, if John is late, then he will not be admitted. The negation of that, he was admitted, therefore the antecedent is not true. And so you would label that as modus tollens. And I have a series of those on the test as well as here that basically allow you to sort of see how in language these rules are used and how you actually apply them. So that last sheet, you definitely want to look at that part, but it's also the case that it's something you want to kind of work your way through. And so let me finish up these last few rules. Let me show you how this works. So the implication commutativity is you show how the arrow goes, and then you tell what rule is being used. Okay? So let me finish up the rules of replacement, and then you can get on your way and you can keep working and you can have some fun. So, we did the first 5 rules. We did up through distribution. The next one is what we call commutation. I'm sorry, we did material equivalence. We got to distribution. We did that one. So we're at commutation. Commutation is basically where if you have a statement like P or Q, you can change it to Q or P. If it's like Paul or Quentin is there, there's no reason you can't say Quentin or Paul is there. Paul and Quentin are there, there's no reason you can't say Quentin and Paul are there. You can switch the order of the conjuncts and the disjuncts. Associativity is saying that if you have all your main operator is a wedge, and then you have a set of parentheses as one of your disjuncts with a wedge, there's no reason you can't just move the parentheses around. If this is, P wedge, Q wedge, R, it means the same thing as P wedge, Q wedge, R. Is there like 2 plus parentheses, 3 plus 5 parentheses closed? That means the same thing as 2 plus 3 in parentheses plus 5. You don't have, where the parentheses are don't make a big difference. The next one is transposition. Transposition is the idea that if you change around, if you want to take the antecedent and make it the consequent, and the consequent make it the antecedent, you have to negate them in the process. Because what happens is if Paul is there, then Quentin will be there. It's basically also saying that if Quentin's not there, then Paul won't be there. Because modus tollens is telling us that. If Paul is there, then Quentin will be there. Anytime Paul is there, then Quentin is there. But anytime Quentin's not there, we know Paul is not there. Because if Paul was there, then Quentin would necessarily have to be there. So if Quentin's not there, Paul can't be there. So you can just transpose them. You can flip them. Next is an interesting one that doesn't come up a lot, but it's called exportation. Exportation is basically this idea that if you have a horseshoe as your main operator and the antecedent is a plus statement, you can take the P, or you can take the first part of you can take either part actually, but you can take the first part and you can make it the antecedent of a new statement, and then take Q horseshoe R. You can basically change this to a horseshoe, but then you have to move the parentheses over the second part. Why? Because this is saying if you have the money and we still, if you come up with the money and the car is still on the lot, then it's yours, right? So P is, if you come up with the money, Q is the car is still on the lot, then it's yours. Then it's also the case that if you come up with the money, then it's the case that if we still have the car, then it's yours. It means the same thing. If you come up with the money and the car is still on the lot, then it's yours. It means the same thing as if you come up with the money, then it's the case that if we still have the car, then it's yours. And that's basically all it's doing. And you can even do it the other way. If somebody says, well, if you come up with the money, then if we still have the car, then it's yours, you can just say, well, basically I can combine this antecedent and this antecedent into one conjuncted antecedent. And finally, we get this thing called tautology. And tautology is basically saying anytime you have a statement where you have like P wedge P or P plus P, you can simplify it down into just P. And the reason why is, with P plus P, it's like saying Paul is here and Paul is here. That can be simply stated as Paul is here. We should know that via simplification. But it also works with the or. If you said something like Paul is here or Paul is here, well, then it's the case that Paul is here. Because if you're saying it's either the case that Paul is here or it's the case that Paul is here, then we know that Paul is here. And that's called a tautology. A tautology is basically where no matter what, the statement has to be true, because the case is in this one, it's either Paul or Paul. Okay, I hope those make a little bit of sense. Make sure to read the lessons, do the work, and the more work you do, the better you'll be in the long run. So good luck.